Hello guys, good morning. This is chapter 10 Circle of NCERT Mathematics. Now, in this whole video we will discuss on the topic circle, basically main focus on tangent. Now, before we jump into the depth of the topic, we should have a common understanding about what is circle. First point is that what is circle? Now, if you draw a circle, what do you feel? Here is the black boundary point that is known as circumference, and if you talk about the center, this is a center. Clear? What do you feel? So, can you provide a definition of circle? How can you provide definition? I think a circle is a collection of all points. There are many points. That means boundary is infinite. Boundary has infinite point, and if you talk about interior, it has infinite points. So, collection of all points in a plane which are at a constant distance. These are at the constant distance. Clear? Distance is fixed. Distance is fixed. That means distance will never change. If this distance is r, then here r, and this is a center O, and suppose this is a variable point P. Here location is that P dash, P double dash. That means a circle is a collection of all points in a plane which are at a constant distance, radius, and from a fixed point, that is center. This is center, this is radius. You also have studied various terms related to circle like chord. This is chord. Clear? Now, segment. Sector, there are many things. These are the sector. Now, in this class, we will start with three lines, relationship between circles. Look at this figure. What do you feel? What do you feel about this? Can you guess here which type of figure, Here line passes nearest to the circle, but here line intersect the circle, but here line touch the circle. So, what do you think? That means there are three types of relationships. First one is non-intersecting. This is a non-intersecting. This is a intersecting line. And now this is a touching. If you talk about non-intersecting line, then this line is defined as a non-intersecting line, and intersecting line, this line is defined as a secant as well. And also we can say this is a secant. Now this line touch only, so we can say this is a tangent. Clear? This is a tangent. So we got three point on here. One is non-intersecting line, second one is secant line, and third one is tangent line. That means here non-intersecting line with respect to circle, here no common point, here no common point, here 2 point, we get 2 point, and here we get 1 point. That point is known as point of contact. Point of contact. And here we got 2 points, one is A, one is B, and 2 points between 2 points AB is known as segment. Clear? AB is known as segment. Now this is very popular figure. I think in today's mostly nobody knows about this, but in dynamics we use more on the basis of to sort out the problem related to pulley. So this is pulley. What is where we can know about this? If you watch old movies, then there are well, if and in well to draw the water from the well, we need pulley. Clear? So this is pulley, and this is fitted over a well which is used in taking out water from the well, used to taking out water. Clear? From the well. Now if you talk about tangent, here this rope is known as tangent. Clear? This rope is known as tangent. Now look at this figure. What do you feel? Tangent to a circle is a line that intersects the circle at only one point. Clear? At only one point. Now look at here. If you talk this, look at this figure. What do you feel? Can you guess? Now suppose this is a circle and here tangent will be this. So this is a point of contact. We got only 1 point. In tangent we got only 1 point. This point is, suppose that this point is P. Then what do you feel about this point? Observe this. We can create only 1 point. If we try to draw any other tangent, then we cannot draw, because at a point of contact we can draw only one point, and if we draw more lines, then that will be the second line. So this is the second line, and we can draw more second line. We can draw more second line from one point on the circle. If our point is situated on circle, then we can draw only one tangent line, but we are able to draw more second line. Clear? We are able to draw more second line. That is the key differences about secant and tangent line. And there are more cases. Suppose that as we know, the circle is the collection of all points. So at circumference at circle there are infinite points, then we can draw more tangent. But here we are talking about only one point. At only one point, that means at only one point we can draw only one tangent. This is a tangent, but this is a secant. Clear? We can draw more secant. This is a secant as well. Here secant, 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 but this is a tangent. So the tangent to a circle is a special case of the secant, when the two end points of its corresponding chords coincide. Here, if you look at this figure, what do you feel? Here, 2 points, P and P dash, P double dash, P triple dash. Then you got more chord. But if this point and this point P and P dash equal, it will be merged, then that means coincide, then we get tangent. Clear? So if you move on, here look at this figure. What do you feel about this? Guys, what do you feel? Look around this. Have you look around you? Have you seen any bicycle or cart moving? Look at it, this wheel. All the spokes of wheels are looking it's ready. This is a radius. Clear? This is whole diagram is a wheel. Now note one position. This is a one position, position 1, P1. What do you feel with respect to its movement? Suppose it moves, then again P1 comes. Do you know this road touch the wheel, and if you consider this road as a line, this touch the line at 90 degree with radius. This is known as tangent. Clear? So the radius through the point of contact, this is a point of contact with the ground, appears to be at the right angles to the tangent. We shall now prove this property of the tangent with the help of, we will prove it. If you extend this line, you will be able to prove this theorem. This is also theorem. Now come at the theorem. Theorem 1 says that the tangent at any point of a circle is a perpendicular to the radius through the point of contact. Clear? What do you feel? Can you prove this? Now look at here. This is a circle and here point of contact, this is a tangent line, and we extended radius OQ, and Q is the point at the tangent. Now, the theorem says that the tangent at any point of a circle is perpendicular to the radius through the point of contact. This is a perpendicular. Clear? So we are given a circle with center O and tangent xy. Suppose that this tangent is xy. To a circle at a point P, we need to prove that OP is perpendicular to xy. To prove. What to prove? OP is perpendicular to xy. This is the proof. Clear? Now, take a point Q. Take a point Q on xy. What we are speaking, we should write as well. Clear? Take a point Q on xy. Suppose here we will write take a point Q on xy. Clear? And other than P, join OQ. Other than P, join OQ. Clear? Now, the point Q must lie outside in the circle. The point Q must lie on outside the circle. Note, if Q lies inside the circle, what happens? If Q lies on the circle, what happens? If Q lies outside the circle, what happens? Clear? So we can say that if Q inside the circle, then there will be one condition. There will be one condition. Here, look at this figure. What do you feel? We can draw only secant. This is the secant. Features of the secant. There are 2 points and segment, but there is no tangent. So if you take Q inside, you are not able to draw any tangent. But if you take a point on the circle, you will be able to draw only one tangent. But if you take Q outside the circle, you will be able to draw 2 tangent. Clear? Here, this is number of tangents. We will discuss later on. Now, here, first we should prove OP is perpendicular to xy. Now, here OQ is greater than OP. Clear? According the figure. Since this happens for every point on the line xy except the point P, except this point, every point there, this line is collection of many points. So OP is the shortest of all the distances of the point O. This is the shortest distance. This is longest distance of the point O to the point of xy. So OP is perpendicular to xy. So we can say that OP is perpendicular to xy. That's the proof. Clear? Now move on the exercise, move on this theorem. What do you feel about number of tangents from a point on a circle? Now next point is number of tangents. This is a number of tangents. What do you feel about this? Look at this. We have discussed this in previous recently. Now if you take interior point, that means if you take a point inside the circle and if you try to draw tangent, then you will not be able to draw any tangent with this point, because this point provides two point and this line as a second line and this is a segment, so we are not able to merge this point. But if you look at this figure and this is a point of contact and you can make only one tangent here. If you take outside that circle, if you take any point outside the circle, then you will be able to draw two tangent and both length of the tangent will be same. So there are three conditions where we think about tangents. So here if you draw a circle and take inside a point and draw a line, then you can get second line, but that means you cannot get any tangent line. And if you take a point on the circle and if you try to draw a line, that line will be known as defined as tangent line. This is a point of contact and it makes 90 degree as well, right angle. We have cleared in wheel as well, where all spokes makes 90 degree with the help of rod. Now if you take and try to draw the line, then you will be able to here. If you use similarity rules, this is also a theorem. From this we can prove this theorem in later on we will prove it. Now this makes 90 degree as well. This is a point of contact and PT1 PT2 is equal. Here PT1 and PT2 is equal. This is a tangent length of tangent. Clear? This is a common point, common line. Clear? This is a center. Now come at the theorem. Second theorem. The length of tangents drawn from an external point to a circle are equal. Can you prove this? Here, first, whatever we speak, you should write as well. Because if you, in exam, you should write in appropriate manner, because here we are providing a solution and try to understand the concept behind this. So what should you write? You should write in a sequence manner, because this our examiner wants from you. Clear? Now here the circle is given with center O and point P lying outside the circle. Look at this figure. PQ and P are on the circle. There are two tangents, and here we will prove PQ equal to PQ equal to PR to prove. Clear? That is the point. To prove PQ equal to PR. Now we join OP. Here we joined OQ, we joined OR. Then OQP and ORP are right angles because these are angles between the radii and tangents. Clear? And according to the theorem 10.1, they are right angles if you make any line and from a point of contact, then you can draw only one tangent and that tangent will be at right angle. Clear? Now there are two right angles here, first and second. So in right angle, OP, OQP and ORP, triangle ORP. OQ and OR is radius, that means radii. So OQ equal to OR. If this is a radius, that means radii, so we can write here. This is the same on the same circle. Now second point is OP and OP of this circle, this triangles, and OP of other triangles, triangle 2, OP and OP. This is a common. Now, so this theorem is like that CPCT. Clear? So according to CPCT, we can say that this is a, if you take this and this here 90 degree is given, that then we can say that this is a similar, this triangle OQP similar to ORP. Now PQ equal to PR. PQ equal to PR. That is the point. This is the proof. You can prove with the help of CPCT. Clear? Now move on next point. This is a exercise 10.1. Clear? Now in this question, how many tangents can a circle have? The first point is how many tangent circle have. What do you feel about this? Can you draw more tangents? What do you think about this question? First thing, if any question is asked by you, then don't be hurry. You should think about this first. How many tangents can circle have? Suppose if we take any circle here, Here suppose this is a circle. Clear? Now in this circle, can draw more tangent? So suppose we draw a tangent. This is a tangent, but if we take one point, we are able to draw only one tangent, but there are more points. So we can draw, if there are infinite point, then we can draw infinite tangents as well. So question says that how many tangents can a circle have? So this question doesn't say, there is only one point. This question doesn't say about the points. So a circle have a collection of many infinite points, then we should not assume from individually from one side that there will be one point. So I think the definition of circle, which is a collection of infinite point, then we can say that we can create more tangents as well. Here there are more tangents we can draw. Clear? So we can say that here a tangent, a circle have infinite number of tangent. Clear? Because a circle has infinite points on it, and at every point a tangent can be drawn. Clear? Now come at next part of the question. Here fill in the blanks. A tangent to a circle intersect it in, here point, here is blank. What will you fill? A tangent to a circle intersect at in what? A tangent to a circle intersect at in only one point. Look at this figure. If you draw a circle first, what do you feel? And try to draw a line, a tangent from this. You can draw only one tangent. That means a tangent to a circle intersect it in only one point. This is a point of contact. Clear? Now, a line intersecting a circle in 2 points is called, here if you try to understand here, what do you feel? If this intersect, this line intersecting, then you got 2 points. So we have cleared about this. This is a secant. Because this gives chord, this gives segment. Clear? This gives segment, this gives 2 points. So this is not tangent line. So we can say this is a secant line. So here we will put a secant. Clear? Now come at the point. Third question. A circle can have parallel tangent at the most. A circle can have 2 parallel tangents at the most. Clear? A circle can have 2 tangents two parallel tangents at the most. Here this is a line which is parallel. These lines are parallel, and if you draw any other line, if you try to draw any other line, then this will not be parallel as well. We suppose if you try to draw, this is not parallel to this. So we can draw only two. We can draw only two parallel lines at the circle which will be tangent, but it will be parallel. And if you try to any other, then you will not be able to draw any tangent. If you but you can draw more tangent, but condition is that, constant is that, question says that parallel tangent. So there will be two parallel tangents. Clear? Then put here 2. Now fourth question, the common point of a tangent to a circle, the common point of tangent to a circle and the circle is called, what do you call? Point of contact. Do you know? We have discussed more. This is a point of contact. Clear? Now come at the next question. A tangent PQ at a point P on a circle of radius 5 cm meet the line through the center O at a point Q so that OQ is 12 cm length PQ. First, we should draw a line. Here we have drawn a line. Clear? Now this is a center and this is a radii which is perpendicular to the tangent. Clear? And we make a right angle triangle here according to question. Clear? Now question says that here the question is a tangent PQ at a point P on a circle of radius 5 cm. Radius is given that, OQ is given that. Clear? Then find the length PQ. So this is a center O and here 5 is given that, here 5 is given that, and this is 12. Clear? This is a point P, this is a point Q, and find the value of OP. Clear? This is a right angle triangle. With the help of Pythagoras Bodhayan theorem, we can find out. So what will be the value of OP? We can find out with the help of this formula. OP square equal to OQ square minus OP square. This is QP square. QP square equal to OQ square minus OP square. Clear? OQ is given that 12 is, so 12 square minus 5 square. 12 square is 144 and 5 square is 25. This is 9. This is 1 and 1. Clear? So QP will be 119, square root 119. So the option will be 119. Clear? Now come at the next question. What do you feel about this? Draw a circle and two lines parallel to a given line. Now, first you should take compass and and draw a circle and line according to the question. Clear? What do you feel about this? Draw in this way. Here. First we will draw a circle and line which is according to the question. Then try to draw a perpendicular line according this. In this way we can draw a perpendicular line. Sometimes it also bisect this segment. Clear? Now we will make a line from the intersecting point. Then we will be able to draw a perpendicular line which passes through the intersecting point and center. Now with the help of this we can draw a parallel line which is at a 90 degree and as well intersect the previous line. Clear? So in this way we can draw and we can complete the questions. So this is the fourth question. Now come at the next question. This is the next exercise and we will meet you next video. So wait and watch for this. Thank you guys.